Hello, viewers. My best wishes for all of you. I am Devashish. I am going to deliver my lecture, today's lecture, in English. That's because some of my relatives and friends living in distinct foreign countries asked me to deliver the lectures in English so that their kids who are not in a good touch with Bengali can easily understand the lectures. Guys, I am not enough rich in English. That is, I am not a Bill Gates in English. So I have to deliver my speeches as slowly as possible. And I think that will help the primary and secondary level students in my country to realize the lecture. So, audience online, the bell rang. Now it is time to start. Here is a list of the most terms I will use in the lecture today, and here is the Bengali translations of that terms which may help the primary and secondary level students in my country to realize the lecture. In the previous video and in today's video and in the next some other videos, I am introducing some theory regarding G.C.D and L.C.M of integers. That theory we applied in our primary and secondary level school mathematics syllabus, but we all, most of all, didn't realize the reasons behind the theory. That is, we could not prove the theorem. In the previous lecture, I stated the most important theorem, first theorem, which had two portions. The first portion of that theorem is on G.C.D of two integers, and the second portion of that theorem is on L.C.M of two integers. In the previous lecture, I have already discussed and explained the first portion of the theorem. So now it is time to explain and discuss and state the second portion of the theorem. Now I am gonna write down the statement of the second portion of the theorem on my whiteboard. The statement of the second portion of the theorem. If L is the L.C.M of two integers, if L is the L.C.M of two integers, what is L.C.M? L.C.M means the lowest common multiple of any other numbers of integers. If L is the L.C.M of two integers, then And what is that integers? We can introduce that integers as a and b. If L is the LCM of two integers a and b, then L by a and L by b, these two numbers are co-prime. That is the statement of the second portion of that theorem. If L is the lowest common multiple of two integers a and b, then L by a and L by b, these two numbers must be co-prime. What is co-prime? If two integers have the G.C.D 1, that means if the G.C.D of two integers is 1, then that two integers are called co-prime numbers or mutual prime numbers. That is the statement of the second portion of previous theorem. Now I am going to explain that theorem. Here given L is the lowest common multiple of the two integers a and b. That means L is divisible by a and also L is divisible by b. So we can write down that L is equal to ax. Though L is a multiple of a, so L is equal to a times x, where x is another integer, and also L is equal to bx in a similar logic, where I am wrong, L is equal to b into y. X, this and this must not be equal to each other. So if L is equal to x, then L is equal to b into another integer y, where x and y are some integers. Now we have to prove that. Look at these two equations here. From the first equation we can get that L by a is equal to x. Similarly, from the next equation we can get that L by b is equal to y, and we have to prove that L by a and L by b, these two integers are co-prime to each other. That means x and y are co-prime to each other. This is the statement we have to prove. What is the proving method? We can prove this theorem by the method of contradiction. What is the logical method of contradiction? The method of contradiction is that first we consider the proposition. Proposition means that statement which we have to prove. First we consider the proposition as false, and then by logical steps we can reach in an impossible environment, in an impossible statement which cannot be possible. That is the contradiction. Why we will reach in an impossible statement? That because we started and considered the proposition as false. That means the proposition is not false, so the proposition will be true. It is the method of contradiction. Now, applying method of contradiction, we have to prove that these two integers x and y are co-prime to each other. So now consider this proposition is false, that is x and y are not co-prime. So x and y has common divisor greater than 1. That means if x and y are not co-prime, then their G.C.D is not equal to 1. That means the G.C.D of x and y is greater than 1. Suppose the G.C.D of that two integers x and y is k. Where k is a natural number greater than 1. Then from the previous lecture we can get that x is equal to km and y is equal to kn, where m and n are another two natural numbers. Though k is the G.C.D of x and y, that means x is divisible by k, so x equal to k times something m, and similarly y is also divisible by k, so y is equal to k times n, where m and n are another two natural numbers. Now putting these two values of x and y into the first two equations, we get L is equal to AKM, that is L by K is equal to AM. Similarly, if we put the value of y into the second equation, we can get L is equal to BKN, that means L by K is equal to Bn. Now we can number the last two equations. Suppose this equation is 1 and this equation is 2. Now from 1 and 2 equations, look at that two equations. Here the right hand side am is obviously is an integer, so the left hand side of the equation L by K is an integer. Similarly, from here also left hand side is the same number L by K. From 1 and 2 we get that L by K is an integer, and though K is greater than 1, then L by K is less than 1. So L by K is equal to M. That means L by K is a multiple of A. From the equation 2, L by K is also a multiple of B. That is L by K is a common multiple of A and B, and which is less than L. Though K is greater than 1, then L by K definitely is less than L. So A and B both have common multiples which is less than L. So L cannot be the lowest common multiple, but in our proposition L is the lowest common multiple of A and B. But here a contradiction arises. A contradiction arises that L by K is also a common multiple of A and B, but L by K is less than 1. So L cannot be the lowest multiple. Why does the contradiction arise? The contradiction arises for that reason that we had considered the proposition, main proposition, as false. That is, we considered L by A, X and Y, that is L by A and L by B, as non-coprime. So that step by step we have reached to a contradiction. So our main proposition is not false. That means the proposition is true. So X and Y. And what is the X and Y? X is equal to L by A and Y is equal to L by B. That means L by A and L by B are coprime. That is the theorem, and that is the reason lies behind that theorem. Thank you very much. That's all for today. Take care and be happy. Thank you.